Hello, my name is Bogdan. I would like to talk about today about trying to somehow incorporate TermIt into some ontology engineering workflow. So I'm just going to go over some of the interesting features that we think could be used for that purpose and how we do that. For now, everything is very ad hoc. So I'm trying to kind of give an overview of this and what could be done, maybe to improve TermIt or how to improve this ad hoc approach. So we'll start a little bit introduction to ontology engineering very briefly. So basically, we have some sort of knowledge base. That's the input. So we have some domain expertise. Let's say we have domain experts. We have reference literature, but we also can have other stuff like the reference literature you can understand in way more general than just some textbook, but also, let's say, company documentation, any sort of analysis, internal terminology like managed vocabularies or controlled vocabularies, and so on. We can also have other ontologies, let's say top-level ontologies in which we want to build our domain ontology, or we can have domain ontologies which are not very specific, but are suitable. So that's kind of what we have as input, and we want to build and have a precise terminology for our output, which should be some sort of domain or application ontology, which should be formalized and tested. So this is kind of overall the like a black box of ontology engineering. So obviously this is a complicated effort and it involves multiple roles. So we have the domain expert, as I mentioned, but you also have the ontology engineers who who formalize the terminology that's being provided by domain experts. So here are some roles of what tasks these could entail in the ontology engineering. So typically there is a text-based definition of terms. So that means a label or multiple labels of the terms, text description, and maybe some examples. And then there is and this task is typically performed by the domain experts. And then we have the formalization part or phase, which performed typically by the ontology engineer because they understand the logic, the logics and the formalization process. And then obviously there needs to be some testing and validation. For example, there could be some sort of verification of conventions that let's say terms have a label and a definition and at least one example or things like that. There could be more sophisticated testing. For example, there could be competency questions. They could be formalized, for example, using Sparkle, and we can test whether the ontology can somehow perform some retrieval and representation. Or it could be something more complicated, maybe in an application ontology. In application with some particular data set and doing some actual application, which is I guess, the best way to test it, or the more thorough way to test it. And there's also possibility to somehow make cross-reference with reference literature that, let's say, the terminology in the domain ontology is covering the reference literature. That means that there must be some sort of term occurrence analysis in the literature, and to say, well, these terms are important and they are covered or they're not covered. So in this context, the TermIt is what is the suitable features of TermIt. In my opinion, or at least for what we've been using it so far, is that we have the ability to define terms in text form. So there is the label and the definition. It is a very interesting feature that TermIt allows to do this semi-automated annotation of term occurrences, which allows us to have vocabulary and to import some texts into TermIt and to annotate them and then export them and do something with them. So this is a good feature. And what is good for TermIt is also that it's suitable for domain experts and for collaboration. So we can have multiple people working at the same time, which is not, let's say, possible with other tools like which we use in this workflow, which is, for example, Protégé. So for Protégé is, I guess, is the what is typically used by the ontology engineers. So we formalize the terminology. For example, we provide a taxonomy formalization. There, obviously, there is some interesting features in Protégé. It allows us to check for logical consistency, and yeah, but it's unfortunately not very suitable for domain experts and collaboration. So we've been doing some experiments with multiple projects, but let's say, I guess the most advanced one is the current one, which is regarding airport safety. So in airport safety, what are our inputs and how we are processing them and trying to use TermIt with this. So there is operational data. So the operational data is there could be multiple data sets, but typically what we have so far is inspection reports. And in these inspection reports, we have information of what has been inspected and what are the findings. So what's interesting there is that there are some categorization, and for example, we can have categorized inspections. Let's say that they could be inspections that are planned and non-planned. And inside of each inspection, there could be different things that could be checked. So there is information about what has been checked in the categorization of it. So there is lots of terms there, whether it is something on the stand on the airport or something on the runway, some signs, some lights, and so on. And there is also categorization of what is the finding. And there is details, which are typically given in text form. So this information could be loaded in TermIt. So, for example, the inspection types in the findings are loaded into TermIt as a vocabulary, and they could be examined by the experts and defined. So, because typically these are just labels and they do not have any definition, it's just a label. And then we can actually annotate the findings, the text, the descriptions of the findings with those terms, for example, or terms from the ontology, and maybe allow for the user to better analyze the findings. So apart from the operational data, we have things like documentation and analysis, artifacts, and so on. So here as an example is the STPI analysis. So in the STPI analysis, again, we have some terms. So I think we are all fairly aware of what STPI is. So very briefly, there is a control structure, which is what are the controllers and the controlled components or the controlled process and how they are controlled, what's the feedback. So these are potentially can be considered as terms. And then there is text, which are the descriptions of the loss scenarios and all the different kinds of constraints. But there are also other concepts there, like the losses, the hazards. So this could be also imported in Protégé in the form of vocabulary or text to be annotated. So when we are doing this so far, that's just what's coming from, let's say, the domain, but or the company, or that's not ontology-based artifacts. So they somehow have to be imported. But this section here could be something that's not necessarily an ontology, but it could be beyond the domain specifically. Let's say we have the domain of the airport, but that's inside like aviation safety in general. So we can probably use the aviation safety ontology, the occurrence vocabulary, or ATA 100, which are two other control vocabularies. So all of these could be somehow beneficial to import and work on for different reasons when building the ontology. Okay, so to import something as an ontology or as a vocabulary in TermIt, there is different ways, but we are using this SCOS import and export feature. It is quite straightforward. If we have a SCOS, we just import it and everything's fine. The problem is that in our ontology engineering workflow, we would like to import it. We would like to import an ontology, let's say, and then we would like to export it and somehow merge it with the actual artifact, which is, let's say, managed in Git. So TermIt is just for the collaboration, and we want to kind of synchronize with some other artifact. So to do this, we use a spipes script. So that script is not possible to reuse. There are some things that we always have to. We also have, it could be parameterized, but what is there's two aspects. So one is that it is important how the ontology is accessed. So is the ontology accessible through a URI, or is it in a triple store, maybe in a graph or in a specific graph, or is it in a local file? There are different ways, but I think spipes allows some way to do that. It's not. It's maybe a little bit of a hack accessing a local file through file URI, but yeah, I think it's I've tested all of these three, so they work fine. So any of those could be done, but yes, the pipeline would have to be changed a little bit for you to be able to do that. What I could see as a problem is if you have a local file, but you want to convert several ontologies, or one ontology that imports another ontology. So then I don't know, that won't work because obviously the imports are using the ontology id, which is not referenceable because it's just in a local file. So that has to be done in a different way. So so that's not really reusable part of this pipeline. And then the other part is that, SCOS format, which is supported by TermIt, allows, it expects some properties. So, there is the pref label and the definition, which won't work if our ontology uses label and comment. So it is important to map those two things, which works both for import and export. So when we import, we have to convert from RDFS label and comment to SCOS pref label and definition. And when we convert back to the ontology after export, we have to reverse that mapping. So here it could be different properties. Not every ontology would use the RDFS label and comment. So that could, it depends on ontology, this part. So during the export, there is something that TermIt could be, I'm not sure we've talked about this, so maybe TermIt already does that, fixes that, but terms when imported, so no new terms, but just imported SCOS and then exported, will change the iris of the concepts, adding this path element poem. So when we export, we have to remove that to make the ontology the same. And so it's something that it would be nice to have, but we don't have yet. Is to somehow assess, well, what's changed in these concepts. What are the new terms? What are the updated ones or the deleted ones, so that we can update the ontology accordingly. So if they're new concepts, maybe we want to classify them if they're classes under taxonomy in the right location, or maybe if there is an update, maybe we want to change that classification, and so on. So maybe I'll just say we don't have anything automated for not ontologies. So if we have, as I mentioned earlier, ATA 100, Ecaers, these are not ontologies. So let's say ATA 100 is typically found in PDF file. Maybe if we are lucky, we can find it in some sort of table, in HTML, let's say HTML table, while Ecaers is in XML format, or it's more complicated. There are several XML files and several tables, CSV tables. So that's not this spipes script cannot handle that. So that should be a different script. We have like modules that do that in spipes. I'm not sure how, specifically for Ecaers, I'm not sure how current it is. And for ATA, there is nothing. But yes, we can have a pipeline that processes some sort of table, CSV table, let's say, or Excel table, into SCOS. So that could be something that could be complementary to this, working with the ontology. Or as we do it now, we have the ontology, we have converted ATA to some sort of ontology and occurrences to some sort of ontology, and then we convert to SCOS. So I just wanted to mention that perhaps not always we want to convert to ontology and then to SCOS. Okay, so about this conversion of the HTML, of texts to HTML, to load into TermIt so that we can find term occurrences. Well, here there are several important aspects. But the most important is that it's probably the best way to use a table, an HTML table, and to form the table in such a way that the text from I forgot to say something important. So to distinguish between just text and text from ontology. So when we just have text, we just make a table if it makes sense to be a table. Otherwise, we can just have the text as a HTML, load it, and do the text analysis there. But in the case of ontology, if we want to annotate text in the ontology, then that would be suitable to use table in this scenario. So, for example, if we have the STPA analysis, we have, let's say, a table of loss scenarios, and we can have for each row the description of the loss scenario, and it could be annotated, and we can find terms from the ontology that we're building, or we can define new terms. What is important in this case is that we want to keep track of the texts and their entities. So the scenario description is associated with the IRI. So we do that by adding a column with the IRI for the entity and a column with the IRI for the property, so that we can say, well, that was a label for that entity, and that was a label or a description for that entity. And this way, when we are extracting the occurrences, we can associate those occurrences with those entities and properties. So for the exporting of the term occurrences, we also have a pipeline. So to do that, the input here is the HTML exported from TermIt after annotation. And there is some there is a nice module in SPipes to extract occurrences. It allows us to process the occurrences. They are represented as tags in the HTML. So that's working fine. And so how that could be used then, these occurrences, is that we can take them, we can classify the terms that we're having, or maybe they're already classified because they are from an existing ontology. And then we can use that, let's say, as an index to look for the loss scenarios, let's say, for this example. Sorry. So yeah, that's it. Thank you. And if you have any question, we can go into more details.